All right, welcome everybody. It's Hugo Bowne-Anderson here. I am very excited to be here today with Ethan Rosenthal from Square to talk about navigating the full stack of machine learning. We're going to start in a couple of minutes, and in the meantime, if you could introduce yourself in the chat, let us know what your interest in machine learning, full stack, data science, all of these things are. Maybe what industry you work in and where you're at. That would be super interesting for us. That'd be great, and we'll get started in a couple of minutes. And yes, we've already got one comment. DP Sidon Spinner has said, please put an extra log on the fire. It's cold here. We'll definitely do so. Things are gonna heat up today, DP. So get excited for that. All right, everyone. Hugo Bowne-Anderson here from Outerbounds. Welcome to our final Fireside chat for the year, where I'll be speaking with Ethan Rosenthal from Square about navigating the full stack of machine learning. It'd be great if on YouTube you could let us know where you're calling in from, what your interest in full stack machine learning are, what type of machine learning you work in, and what vertical and such things would be super interesting. And that'll allow us to tailor our conversation to the audience as well. And we'll get started in a couple of minutes. So we have David Wolf, looking to build a model for personal projects. Great. Theo Howard remembers Hugo's classes from Data Camp. Awesome. And Theo works at the Wisconsin School of Business, helping instructors with online course content. Fantastic. All right, everybody. Hugo Bowne-Anderson here. Boy, am I excited to be chatting with Ethan Rosenthal today from Square and from Life and from New York City. Ethan and I also have diverging yet converging trajectories, both having worked in basic science research. He may say he worked in real science, being physics, whereas I worked in biology, although I did work in biophysics. And we have a question, will this be recorded? This will be recorded. It's currently being recorded. This will stay in perpetuity on our YouTube channel, or until YouTube gets bought by a megalomaniac billionaire and then attempts to have a different business model. I'm just kidding, of course. That would never happen. So we have DP Sidon Spinner working in tech bio monitoring. Very cool. Todd Garner's a student learning ML and AI. Sanam Gupta, Bay Area, California. Fantastic, works in ML and natural language processing extensively. Here to understand the full stack to be successful in finding a job as an ML engineer. Ran from Boston using a MERN stack. Fantastic. Theo's also an artist. Loves the controversy around AI and art. That's really hot right now. We have Matthew Hess, a full stack dev, considering focusing on data science career path. Jared, working in ML, applied to vision and remote sensing. Very cool. Lots of interesting stuff. And I honestly think, it's 2 past the hour. So let's take one more minute. We've already got 40 people here, which is super exciting, particularly given it's December and really the holiday season is upon us. And that has been, a pretty wild year on a lot of fronts. So let's take a couple more minutes. If you could introduce yourself in the chat, let us know what your interest is and who you are and where you're calling in from. I'm dialing in from Sydney, Australia. Ethan is in New York City. We have Zulfia Dito, who works in healthcare. Fantastic. And we'll just take one more minute. Oh, hey, Ujesh just said, "Hey Hugo, hey Ujesh." Ujesh works at a fascinating company called Moneyline, and they're using Metaflow, which we work on, of course, to power all of their machine learning work. So, hey Ujesh, and of course, everyone, if any questions come up during the conversation, put them in the YouTube chat. We'll do our best to get to them. If we're often not able to get to all of them, which is why we have an Ask Me Anything, an async one on our community Slack afterwards, and I'll put the link into that. Yeah, please ask as many questions as possible that are relevant. However, for some definition of relevance. All right, Ethan, let's do this. I think people didn't come here to listen to me wax lyrical. So why don't you turn your camera on? I'll stop sharing my screen and we'll jump in. Hey, Ethan, what's up, man?
Not much. How you doing?
I'm really well. And it is Thursday here, which means getting closer to the weekend, which feels good.
Just about there. I mean, Fridays are kind of chill days anyway, right? So it's almost the weekend.
I prefer Friday to Sunday. Sunday, I'm already stressing about Monday. So I think because we're constantly living in the past and the future, like Friday's a great day. I'm just sitting there fantasizing about the weekend, essentially.
Yeah, same.
Friday and Saturday are the best days. Couple more people just said David Bickham is a data scientist focused on personalization and recommendation systems in LA, which is great. And actually, that's interesting. You and I were introduced to each other originally by Jacopo Tagliabue. I would have got that slightly wrong. But he is someone who works in recommendation systems a lot and thinking through and reasoning through and building recommendation systems at what he calls at reasonable scale, right?
That's actually how I got my start doing data science, was in recommendations, definitely at reasonable scale, not at very large scales. So
amazing. And I am actually so excited to, I'm going to put this thing in the chat. With Jacopo, we've just built a tutorial on recommendation systems using Metaflow. So I've just put that in the chat. But one thing we may get to at some point is thinking through what he means by reasonable scale. And for those joining, if you haven't heard this term, the idea is that, a lot of the conversation around machine learning, deep learning, AI, all of these things, data science, are dominated by a handful of very large companies who do it very well, such as Google. And you can think Fang and a couple of others, and essentially. But what does the long tail? What does the 99%? We are the 99% of machine learners. What is and you're in New York City, so you're in Soho. You're not so close to Wall Street, but you're closer than most. So before we actually dive in, and I'm really interested to hear about your start, particularly as you do come from science, so to speak. But
nose up in the air science. Yes,
absolutely. Physics at Columbia University science, right?
Yeah.
Upper Manhattan, whatever that means. North of 110th Street.
The upper West Side. Yes.
You can't do that. Morningside is okay. So I did want to say, so I mentioned this. We will have we'll try to answer as many questions now as possible, but if any of your questions remain unanswered, as they may, please do come and join our Ask Me Anything on our Slack. I'm posting the link to that. There's a channel called AMA Guests. And before we jump in, for those who don't know what we do at Outerbounds, we essentially work on infrastructure and productivity tools for data scientists that allow them to focus on the top layers of the stack, on building models and doing science while having easy access to the bottom layers, such as compute and data and versioning and orchestration. And we do most of this through the open source framework Metaflow at the moment, but we're very excited to be working on a platform product, among other things as well. I have to do the obligatory, if you enjoying this, hit subscribe. I don't even know, like wherever that thing is, hit subscribe and share with your friends if you think it'll lead right across. But we're here today not to talk about any of this stuff, but to chat with Ethan, who is a data scientist at Square, has worked as a data consultant and used to be a scientist who completed his PhD in physics at Columbia University. We're here to discuss the wild west of full stack machine learning and just how to make sense of this really large space, all the feature stores, metric layers, model monitoring, and more, with a view to deciphering how to think about this, what mental models, tools, abstraction layers are most helpful in delivering actual ROI to businesses using machine learning. But that's enough out of me. You, Ethan, are an AI engineering manager at Square. Like myself, you used to work in basic science research. Can you tell me a bit about your journey from working in basic research to AI and ML engineering?
Sure. Yeah. So I got my start in physics, majored in it in college, and then came up to Columbia to do a PhD in physics, and never really planned to program for a living. Like I took one programming class in college, like in the math department. It was like a numerical algorithms class where they taught us MATLAB, and I programmed in MATLAB in grad school. But then, yeah, wanted to get a job, wanted to stay in New York City, and so I graduated in like 2015, which was right around the time that kind of data science was starting to pop off and everything else. And so I spent my last year of grad school teaching myself Python. I was like trying to decide between R and Python at the time. There's also like, I guess back then, like people were worrying about Scala as well. They thought that that was like the future of data science, which thankfully did not become that. Um, but yeah, I ended up I did a boot camp or a fellowship with this organization, Insight Data Science, which was for PhD students who were interested in data science. Back then, like a lot of people, I mean, still like the definition of data science, I think, is a little fuzzy, but it was even fuzzier back then.
Yep.
And so did a boot camp with them. They got like my foot in the door at a couple different companies to interview, and then ended up working at this company, Birchbox, in New York City back in 2015. So,
And correct me if I'm wrong, but Insight, and I may actually be wrong, is a fellowship. As you said, it's tailored towards STEM graduate people who've done graduate school in a STEM field, helping them transition to industry. But their model is that it's free for the student, but the companies that recruit then pay the tuition, essentially, which is an interesting incentive system. You can have boot camps that aren't incentivized to get any people jobs besides for social proof, essentially. Whereas this, they get they get their money by getting you a job. Am I right?
yeah, it was like a
Yeah.
perfect alignment of incentives.
Yeah.
I was a very poor grad student at the time, so there was no way that I was gonna like pay money to like pay tens of thousands of dollars a year to do some boot camp. But yeah, their setup at the time was it was entirely free. It was a 6 or 7 week program, and they had a 100% job placement rate. So everybody who had gone through this program had gotten a job making like not a grad student salary anymore at companies that were hiring data scientists.
Yeah.
And sure enough, that's exactly what happened with me. I mean, I went through the program. It was very difficult, very stressful, everything else, but ended up interviewing at some companies through them. And yeah, the Birchbox hired me, and they paid some sort of recruiting fee back to Insight, but cost me nothing and got me my first job.
Yeah.
And I got that
And
training for free.
that's amazing. And that's where you were working on recommendation systems?
That is, yeah. So I went to Birchbox, which was one of the first kind of like box-based retail companies. There were a whole bunch of these back then. There still are some now, but the way that Birchbox worked was you could subscribe and get a box of 5 beauty samples sent to you every month in the mail, and so you could try out different beauty products. And then they also had an online store where you could order a full-size version of the product. And
Mhm.
so it's actually fascinating work because I did kind of half recommendation systems where we want to make sure that we're sending products to people that they're going to like, as well as kind of online recommendations on the website. So like through like typical e-commerce stores, given that you've purchased these products, what other products might you like to purchase? So that was like half of the work, but the other half of the work was integer like optimization problems.
Mm.
So we had hundreds of thousands of boxes that we would be sending out each month, and a box has to have 5 items in it. But you have different quantities of those items in your warehouse, and certain customers can get certain items, certain customers cannot get certain items. So if you don't have curly hair, you should not receive a curly haired shampoo or something like
Mhm.
that. And so this whole thing becomes this giant optimization problem where how can we assemble the optimal boxes for people subject to all sorts of constraints on how many units do we have in the warehouse, who can get what, and everything else. So it was a very interesting first job.
Yeah, amazing. And I do feel like thinking through what you learned before going on the job, recommendation systems are things we talk about a lot, but it's not actually, it's highly you can't just learn how to build a recommendation system kind of like you can a computer vision algorithm in a notebook or this type of thing. So was there a pretty steep learning curve in terms of figuring out how it actually works in practice in a real job in a real company?
Super steep, because especially I would say that still there's no standard textbook on recommendation systems. Like if you want to learn deep learning, there are standard deep learning books that have been put out now. If you want to learn kind of standard supervised learning problems, like you can pick up elements
Mm,
of statistical learning and dig through the equations and learn logistic
totally.
regression, from a super deep perspective. But with recommendation systems, a lot of them, I guess there was some academic work at the time, of course, but a lot of this was driven by industry, which is maybe doesn't have the same incentives to put out educational materials around how these things work. And necessarily these recommendation systems are really a function of the environment that they operate in.
Mm.
Um, and like you can only really test them when you actually test them in production and things like that. And so I definitely had a hard time trying to wrap my head around everything, but spent a lot of time trying to like read up on the old Netflix prize and things like that, and like digging into there's very few open source libraries back then for learning about the stuff and kind of like sparse blog posts that people had read. And so definitely a steep learning curve. I ended up writing to help me to understand what I had learned. I ended up writing like a series of blog posts to try to like solidify my understanding of the field back then. Um, and since then, the field has only grown and changed and everything else.
And are all of your blog posts on your website?
They are ethanrosenthal.com. So
Great. And I'm actually going to just put that in the chat as well. Um, we already have a bunch of interesting questions. VM Boston's question is wondering how much a data scientist who does ML should invest in full stack ML or leave it to the experts who can deploy the model. Now, that is what we're here to talk about. So the entire hour
yeah,
will be dedicated to that. But I think maybe thinking about your career and your trajectory early on as an early stage data scientist coming from academia, presumably your skill set played to building models and feature engineering and this type of stuff, not necessarily doing cluster configurations and like cron jobs and scheduled deployments and all of these types of things. So maybe in your first job as a data scientist, what was the focus on, and what other people did you need maybe with more platform engineering skills and that type of stuff?
yeah. So that first job, even when I was trying to decide where to go, which ended up being an easy decision because I got one job offer for my first job, so I took that job. But
Awesome.
it was high on my list originally. But like when I was doing that boot camp, we had a bunch of companies come in and tell us what data science meant at their companies. And even back then, there was kind of this split between people that are doing more analytics and then people that are doing more kind of what we would now call machine learning engineering. And I don't feel like
Mm,
that was a very popular term back in 2015. And so back then, I found myself gravitating more towards like putting models into production, and I was interested in that. And this role seemed to have some of that. And so I would say that at my first job, for the recommendation systems, there was some things that I could do. Like I was definitely allowed to train models, for example. I kind of had free range over like a big cluster that existed in a data center for me to train models and things like that. But the actual model deployment process was sometimes a bit difficult and definitely outside of my wheelhouse.
mm,
Um, I would also say that back then it kind of depends what you're working on in terms of what are the kind of production requirements required of somebody to push their code out. So for something like recommendation systems, it's not, and if you're at a reasonable scale, it's not the end of the world if somebody gets served a bad recommendation. I mean, if Amazon puts out a bad algorithm, because they're at such a scale, then maybe that is even going to cut into their margins. But at our scale, it was kind of lower stakes, and so I was allowed to kind of play in that world a bit, even though I did not have like a background in software engineering. Like any code that you look at that you wrote in the past, you should shudder whenever you look at your old code, because ideally you've learned something since then. And if I look back at the code that I wrote then, it was probably not production quality code. I didn't write tests, any of these other kind of hallmarks of modern software development. But that was okay at the time. One, because it was kind of low stakes that I was operating in, and two, because I think that nobody really expected kind of production software engineering out of machine learning people back at that point in
Yeah,
time. It was hard enough to find anybody who could just kind of program up some of these algorithms to begin with. And so like production level software engineering would have just been a very nice to have.
absolutely. So I want to learn more about your journey to being an AI engineering manager, but we've used the term ML engineering enough, or machine learning engineering, to maybe reason through what it actually means. So what does a machine learning engineer do in your experience?
Yeah, it's a good question. I would say that maybe a definition is somebody who builds probably machine learning models. Maybe it could be like a statistical model, and the boundaries between statistics and machine learning are pretty fuzzy. But I would say that they build this model and it gets used in
Mm-hmm.
some sort of an automated fashion, is probably the best definition that I have. So like you might have a statistician who is building a model, and then they run inference on this model. They interrogate the model in order to try to understand some behavior that exists. But this is more of like an offline process that they're doing. But I would say that a machine learning engineer they build the model, and maybe the model serves predictions behind an API. Maybe the model runs once a day and it generates some predictions that get written into a database, and then somebody
Mm,
else ends up using those predictions. Um, Maybe, yeah, but I think the model gets used in some sort of an automated fashion is probably
yeah.
the best definition that I have.
So then in some ways it is a data scientist who specifically builds models that are deployed to production or something along those lines.
Yeah, yeah.
Yeah. But they're not necessary, because I think maybe the term engineer is so overloaded. We have ML engineers, data engineers, platform engineers, and it's more on the kind of the scientific side, focusing on the top levels of the stack that we'll get to.
Yeah, yeah, I think so. And that's like at Square, we have the term machine learning engineer. And I think that what I've said largely matches what those people do. And there might be, at a bigger company like Square, there is a platform team where they are maybe responsible for building out a platform to allow for serving of models with low latency and high concurrency and everything else
Mm,
that you might care about at scale. But the machine learning engineer, they are the ones who are building the actual model, and probably the ones who are responsible for what the model, like how the model impacts the ecosystem that it operates in. So
yeah,
models generating predictions, maybe somebody's making decisions on those predictions. And so how do you kind of track that process? That's probably the job of the person who built the model.
great. And so Sonam Gupta actually has a fantastic question. By that definition, Sonam asks, ML engineer would be the one handling the models in production after data scientists have built them. So I think what I want to say is it's the ML engineer who builds them, and they are the data scientists in that sense. But are they responsible for maintenance then, I suppose, is another way to reframe that question.
Yes, but I think it depends what maintenance we're talking about.
Yep.
So like when I've worked at startups, maybe like oftentimes at a startup, your job encompasses more roles. You don't have as much specialization, and so maybe at a startup, you have to build the API that you deploy your model behind, and so then you are responsible for everything from like the actual API and compute layer all the way up to the how is the model performing and things like
Mm,
that. Does the model need to be updated with fresh data or something like that? Um, what I've found at say somewhere like Square or somewhere where you have a platform team, maybe the platform team is responsible for making sure that the API continues to work, like it doesn't, run out of memory or something like that. But
mm-hmm.
the machine learning engineer, they're responsible for making sure that the model is doing its job.
Yeah,
So it is
exactly.
generating high quality predictions. Yeah.
Yeah. And you may have data engineers who are responsible and accountable for the data pipeline actually working correctly to feed into the feature engineering and machine learning models.
Yep. Everything is unfortunately connected, and assigning responsibility to each of these parts is important to make sure that the whole pipeline runs.
Absolutely. So we've already jumped into some fascinating aspects of what the full stack looks like. I am now interested in just returning back to your journey and how you went from your first job to being an AI engineering manager at Square. Oh, pardon me. Sorry.
Yeah, so maybe hopping along, I went from that first job to a second job, which was at a very similar type of company. I think one thing to note about this second job was that I joined there it was again a box-based retail company, so similar problems. I joined there as the first data scientist, and I built some things, but then I was very lucky at that job because uh, we hired some software engineers that I got to work alongside, and that was kind of the first time that I really had other people reviewing my code, and turned out I had a lot to learn. But like being in that situation where you can get like very good feedback on what you're doing and learn best practices from other people was extremely helpful. And so built out a bunch of things there. Left to do some freelancing for a while. Again, focused on kind of productionizing machine learning at various companies of different sizes. And then like 6 weeks before the pandemic hit, so like January 2020, I ended up starting at Square. And so I joined Square. When I joined Square, I was on the risk team, building models to detect fraud. Um, and I can talk some about that. That had its own like very fascinating like machine learning engineering process behind it. And then midway through my time at Square, I ended up switching to my current team, which is called the Conversations team, where I started out as an individual contributor, and now I manage a small team of engineers.
Fantastic. And I think that's a lovely segue into, I did want to talk about the types of business problems that Square uses data science and machine learning for. So if you want to jump into those, and then we can kind of discuss, at a high level, how Square will use the output of data science and ML, and then jump into the weeds as to what actually happens.
Yeah. So I think like the oldest machine learning team, I think at Square is the risk team that I originally joined. So Square is commonly known as a company that processes payments. So if you've ever gone to a coffee shop, you might have seen like our little devices that you can swipe your card at. And so that's where the company started.
And are those the little white things?
They started as like the little white things that you could plug into the headphone jack of your iPhone way back in the day, where you could actually, back when people used to swipe cards. And now there's a whole suite of hardware that is sold.
Awesome.
But yeah, I think like risk is a big issue for the company. So you can imagine all sorts of payment fraud that might occur. If people steal somebody's credit card, and then use it as a Square business, and Square can be on the hook. And there's other pretty large sources of risk that the company takes on, especially because we're focused on small businesses, which have not been traditionally served by larger banks because they tend to be riskier to deal with. And so so the fraud team, that's like the oldest team at the company, which is where like a lot of the kind of platform level tools ended up being built out. And so that world is like, you can imagine lots of classification models. Is this a fraudulent payment versus not? I feel like this and like spam are like the classic classification applications that you learn about in class. So that's where it started. But then there's, I don't know. There are a lot of machine learning teams now at Square. There's like maybe 20 or something like that. And so it's kind of spread throughout the company. So everything from like lifetime value prediction of the businesses that sign up with us, looking at their churn. We have a team that does like lending to small businesses, and there's a lot of work around that. All the way to my weird little team that exists kind of in like a corner of the company. So we build a messaging hub for Square business owners. So if you're a business owner that uses Square, all text messages and emails that you send out to your customers or that customers send to you all exist in one place. And so you as the business owner can go in and you can view your conversations with all of your different customers and message with them and things like that. And so the broader team works on this product. My small team that I manage, we build, I guess I'll call them like smart features for this. And so perhaps unsurprisingly, it's a lot of natural language processing and things like that. So we have a chat bot. If you want to, let's say you book an appointment at a hair salon, you might get a text message confirming your appointment. And that text message will say, if you need to cancel or reschedule, then you can respond here to the Square assistant. And so we have a chat bot that will talk with you in natural language to update your appointment if you need to, as well as maybe you've seen, Google will suggest a response for you to send back to an email that you get. We have a similar feature that we've built for the business owners. So they get a customer inquiry. We can suggest a response for them to send back. And we're using kind of like the hot thing of the moment right now, large language models in order to do that. And so yeah, lots of applications here.
Yeah, there are a bunch of fascinating applications. And in fact, Sanam Gupta just had a question. Are there any use cases of NLP in Square? If yes, can you share any examples? And without even seeing that, you answered it in real time. We have a bunch of other very interesting questions that I hope to get to. But I do, before getting into some of those, I'm interested in if you can tell us about how you measure success of machine learning projects. And if they're out of any of the ones you just said, feel free to talk about them or more generally.
Yeah. So I joined the risk team. I wanted to join the risk team when I came here, and I did because I liked that their definition of success was very clear. So, I mentioned that I used to work in recommendation systems, and you can run some A/B tests with recommendation systems to convince yourself that you have, proved value for the company, that you've made the company money and things like that. But sometimes especially when you're at reasonable scale, you might need very long time periods to convince yourself that the improvements that you've made to an algorithm have given large impact to the company. And so I was very interested in the risk team here because it's at a large scale and we're dealing with money, and like the best way to kind of measure success is with money usually.
Yeah.
And so on the risk team, we could do things like that. So we could run A/B tests where maybe you start sending some payments to one model and other payments go to another model, and then you can measure how much loss did we incur due to fraud from either model. And so that ends up just being a fairly straightforward way. I mean, it's not perfectly straightforward because with fraud, your losses are like technically unbounded. So if you have a bad actor who figures out that they can steal your money, they're going to steal as much money as possible. And so it ends up being a bit of like a causal inference problem to actually do it right. But that ends up being a very nice way to do this. On the chatbot side of things, the chatbot can kind of back out and ask the business owner for help if it's not able to solve a problem for somebody. And so we can measure basically like how often does it complete its goals that it has. And so that ends up being kind of a very clear measure of at least that model's success.
Cool. I do want to jump into tooling. But before that, you did, piqued my interest mentioning causal inference. I'm wondering if you can tell us a bit more about the role of causal inference in machine learning and more generally in data science.
Yeah, I will admit to not being super well versed in this. But I think like if I were to put on my like thought leadery, futurist hat or what have you, I do think that this is going to become more and more important for data scientists / machine learning engineers. Like one of the things that I noticed when I worked on the risk team was that we had a lot of great tooling, which we can chat about, for building models quickly and deploying those in order to like target fraud attack vectors and things like that. And so it was actually that problem wasn't so hard. The hard part was actually understanding the impact of your model in the ecosystem that it operated within, especially when your model is impacting that ecosystem. So for example, if you choose to block a payment from going through, then you might not get any ground truth to know if that was truly a fraudulent payment. And so being smart about the actions that you choose and being able to model those actions and kind of infer what would have happened if you had or had not taken those actions ends up being pretty important and ends up being a causal inference problem.
Yeah, absolutely. Well, let's jump into tooling now. As you know, and I've written about and we've talked about previously, we live and work in an age of feature stores, model monitoring, metrics layers, experiment trackers. I mean, the list goes on and on and on. How do you think about separating the wheat from the chaff, and particularly with an eye towards what tools and types of tools to bring in at Square?
Yeah. So to be clear, actually, maybe for some background, my team kind of we end up basically bringing in our own tools and choosing what we use. We for various historical reasons, we actually don't use the platform level tools that exist at the company. And so there's tools that the company has chosen to bring in, which I think is a very different decision than the tools that an individual team needs to use. I think to start, the question is, do you actually need these tools? Is this actually a pain point for you right now? So I think like feature stores are really hot, and like I've been pretty interested in feature stores. I got interested in them when I was on the fraud team because we had an internal feature store. And
maybe you can just define what a feature store is as well,
yeah,
for those who
good
don't know.
call. So I would say that a feature store is ideally a feature store is a way to generate. It's a kind of like a database to store historical features that you would want to use to train your model. So if you think of like a conventional classification model, let's think of like scikit-learn. We have our X design matrix, our matrix of samples and features. And a feature store would be a place where you can store all of the features that are associated with a given sample. And you can then train your model off of this. But then at the same time, the feature store will also serve up those features in real time when you need to possibly perform real-time predictions with your model. And this way, you can kind of guarantee that the way that your model is trained matches the way that your model gets used in production. Because this is like a classic failure mode of models where you train your model off of historical data, but then maybe you can't serve up those features in real time with low enough latency. So like an example at Square would be, maybe we want to understand how, like, what was the fraction of times that this card was declined in the last 60 seconds? Because maybe if somebody's trying to use this, maybe they're using an API to try to make payments with this card at lots of different merchants and it's getting declined at a lot of them, then that ends up being a good signal that this is a risky event and this might be fraudulent. But to be able to track that data historically, you need to be able to know at the time that somebody attempted that payment, what was the trailing 60 seconds of events? What did those look like? And then also in real time, you need to be able to calculate that number at kind of every point in time. And so a feature store ends up being the way to do this. And in fraud, it ends up being extremely important because those types of features are hugely predictive of these sorts of events that occur. But in other areas, you don't really need a feature store. So for example, my current team, we largely just deal with text. So like, what was the text of a message that was sent? You don't need a feature store for that. You just need a database. Or on the flip side, if you don't need to have super high latency with the features that you're serving, if you don't need to have them to be really accurate at the time that you're serving them, then maybe you can just hack your own feature store. This is what I did at one of these reasonable scale companies that I worked at. I would like once a day run a giant SQL query and load, like, to calculate some features and load that into memory and then use that to serve these. And it was good enough. It was good enough for the problem at hand. And so yeah, I think that's maybe one thing, is understanding what exactly do you need. The other thing is that usually people are thinking about these things after they've already gotten started. I think it's kind of rare to have like a perfectly clean slate to start your entire ML ops journey or something like that. And so looking at where you are and what are your current pain points, I think is And like, are they really big pain points is another piece to this. And then I think one other thing to talk about is like, I think being cognizant of the fact that there's a cost to everything. And so, you know, I feel like you often hear from people saying, "Oh, why don't you just use X or why don't you just use Y, and that will solve your problems." But to use any new tool, you're going to have to learn how to use the tool, and it's a specific tool. The field is young right now, and so the probability that somebody new joining your team is going to also understand this tool might be low. And so, and like any tool ends up being an abstraction layer that you are adding into your system. And so, uh, is it going to be worth it? Is this a large generalizable problem that you see across lots and lots of different models? Or is this just a specific thing that you need for this one task? If it's something specific for this one task, then maybe just hack your own solution for that task. And then if you find that this is starting to become like a larger problem, then maybe you need like a dedicated tool for this.
I like that a lot. And I like the idea of bringing it back to what problems you're trying to solve and then considering the costs of adopting new tools, both personal costs and professional personal costs and organizational cultural costs. I suppose also people are generally interested in like when people are learning about this type of stuff, like, wow, to get a job, do I need to know about all the model monitoring tools and experiment trackers and metrics layers and all of this? So what advice would you give to people on what they need to know about the space more generally?
I would say no. They don't need to know about any of these things.
Mm,
I think like I I would guess that there are lots and lots of people who are not using experiment trackers. It would be helpful if there were more. I just started using one like a year or two ago at
mm,
Square, and it's been great. But people got by for a long time beforehand without using it, and I don't think like to pick on experiment trackers. I don't think that that's like a skill. I can't imagine somebody interviewing about that skill and wanting to know, do you know how to use weights and biases or Comet or something
mm.
like that? When I think of like it's kind of like foundational skills that you need to have, and those are not very often associated with a tool, I would argue. Like, programming, do you know SQL? That's great. I would if you don't know if you know Redshift but you don't know Snowflake, I feel like that is perfectly okay. I
Yeah.
know when I was first looking up job postings coming out of grad school, you would like the problem with the job postings is that they often post like this is our stack, like these are the technologies that you use, or they're very bad and they want you to have experience with like this database or something like that. And
Yep.
I have my doubts that you know if you only have experience with MySQL and not Postgres, that unless you're getting really deep into that database, it's probably perfectly fine as long as you know SQL. Uh, yeah, and so I think, I mean, there are certain areas like maybe this is a PyTorch only company, and if it's a very hardcore deep learning role, then they want you to know PyTorch before you come in, even if you already know TensorFlow. But
Yep.
yeah.
Cool. Michael Ward has just written in the chat, Ethan, you're hitting all the right notes for me about limiting the number of tools because each one has a cost. So that's cool. And someone called Joshua Ainsley says, hi, Ethan, been a while.
Yeah, I know, Josh.
Josh has a question around learnings for moving from an IC to a manager. Now I'm going to shelf that question because that's something I want to come back to later, but I just want to specifically say that we're going to come back to that. Hopefully, P has a question. So raised hands emoji, very good. What are the essential ML libraries that we need to know and use to help land a full-time data science job?
I think they're the same ones that have existed for a while. So like if you're on the Python stack, scikit-learn is still very, very popular. We ask interview questions here where you're allowed to use scikit-learn. And so if you know how to use that, then it's a lot better than having to program logistic regression from scratch. And so I feel like it's basically the PyData stack, scikit-learn, pandas, NumPy, I think continue to be like the workhorses of a lot of this. If you need to know deep learning, then TensorFlow or PyTorch are probably fine. And yeah, I don't know. I think those are it. Spark is starting to get popular. I still don't know Spark. So I've somehow I had to use it a tiny bit at my first job. It was really painful, and I've somehow managed to avoid it this entire time. And so I hope that some of you can as well.
Yeah. And I don't know about landing jobs per se, but something which allows you to do fast boosted trees. XGBoost is one example. There are others as well. But
Yeah.
I think if you've got, I mean, I always say that if you can build random forests, boosted trees, and do a bit of deep learning, that will help you answer most machine learning questions, right? So if you know some scikit-learn, some deep learning of some sort, and some boosted trees, I think that
100%. We
that's
are
very
big fans
useful.
of XGBoost at Square.
Awesome. And yeah, but the stack, I mean, NumPy and Pandas and Matplotlib and a few of these other very like foundational PyData, SciPy packages are incredibly useful.
And I think just being comfortable with using those libraries. I know pandas can be kind of complicated. I still get confused by the API and everything
Yep.
else, but kind of the more comfortable you are and the quicker you can kind of slice and dice your data, then it's all of that's just going to pay dividends and definitely be helpful during interviews to move through the interview fast.
Absolutely. And related, knowing your way around Jupyter ecosystem, notebooks, and lab, and can be incredibly useful. And
yeah,
a bunch of basic bash and terminal stuff as well.
Yeah,
Goes a
I
long
my
way.
team, they're big fans of bash and make files.
Yeah,
So I'm not going to tell anybody to go out and start building your own make files, but I think a lot of terminal stuff you will come across, and it can only be helpful to get fast and nimble with that.
absolutely. And then we're going to get to this later, but some basic software engineering skills. I mean, I would say maybe top 2 or 3 are version control, refactoring. I don't know what else. What else do
It's good to know how to write tests, even if they're
tests,
very
of
simple.
course.
Yeah.
Yeah, absolutely. Yep. Testing code. Also data testing can be incredibly useful. Using something like PyTest or something like that can be really cool.
Our world is harder than our testing world is much harder than the software engineers testing world. So
because it involves a lot of the real world.
Yeah. Data changes. So
Yep. Data does change. I love that two-word sentence. Such clarity and precision. I want to move on to kind of what the full stack of machine learning and data science looks like. To kind of seed this conversation, what I want to do is just show a figure that I show every now and then, just as a conversation starter. This is one vision of the full stack of machine learning, where we have data at the bottom. You need some compute resources. Then as your flows start to become, or your projects become larger, you need to think about orchestration, then versioning, and not just versioning code, but versioning code, data models, thinking about deployment. Maybe feature engineering comes in here somewhere, but maybe that's baked into modeling here. And one of the reasons I wanted to show this figure, and it comes back to a lot of the questions that people have asked in the chat, and that we discussed earlier about what data scientists need to know. Scientists generally care more about the top layers of the stack, whereas infrastructure and platform engineers really care about the bottom. Someone said we've lost audio. You can still hear me, Ethan, correct?
yeah, I can hear you.
And I can hear you. I'm just going to type, has anyone else lost audio also? We'll just keep talking. And if a lot of people say they have, we'll figure it out. Okay. Okay. Everyone else seems to be able to hear fine. So I was going to tell Jill that it must be them, but they can't hear me. So, but back to the topic at hand. Scientists really want to be thinking a lot more about the top layers of this stack, but have easy access to the bottom layers of the stack. That's how we tend to think about it at Metaflow and Outerbounds. I'm wondering how this resonates with you, what you'd add to it, and how you think about the full stack more generally.
Yeah, I think that data scientists are largely like that here as well, where you want to focus on the modeling, but you want to have access to all of the superpowers that the cloud gives you, right? So I want to be able to. I don't want the scale of my data to matter. I don't want to have to wait for what I'm doing. So I want things to be fast, which might mean that I want things to work in parallel. I want to be able to store my data, as much data as I want, um, and yeah, you want to focus on the modeling. I do think that unfortunately nowadays, well, unfortunately right now, and to be clear, I haven't used Metaflow, so maybe this solves everything. But the more you try to avoid the lower parts of that stack, the more you try to avoid touching the cloud, touching compute, and things like that,
Mm,
the harder time you're just going to have,
yep.
because uh, because inevitably, like, our abstraction layers are not very good right now, and so
Hmm.
like my team is on AWS right now. When I was on the fraud team here, they were on Google Cloud. Um, and so I've like worked across both clouds. We do have some platform level tools that start to do a good job of abstracting away like the compute layers and things like that. But still, inevitably, you kind of run up into these like nasty edges to all of this. And so when you start to think of things like permissions, especially at a big company where security and networking are very important things, then you start to bump up into permissions, which ends up like pulling you down into those lower layers of the stack. But anyway, in terms of what I like, how I think about it, I do think that that orchestration layer that you had, I think that that's like one highly important part. I think a big part of machine learning work is the fact that you have to work local, like you want to kind of write your code locally, but you can't really do your work unless you're in the cloud. And so, software engineers, like a lot of times they can write their application code locally, they can spin it up locally, they can test it, run all of their tests locally, and then they, can kind of deploy it up into the cloud. But in our world, like training your model on test data locally is, you can find some bugs and you can write some tests and things like that, but you can't actually train your model often unless you're doing it somewhere up in the cloud.
Yep.
And so but like it's kind of difficult to work in the cloud. And so you want to work locally, but then you need to deploy everything up into the cloud. And I think minimizing that cost of switching from local to cloud is important and is very difficult right now.
Yeah.
But that orchestration layer really, really is it. It's like, all right, I want to do all of these things, but I want to do them up in the cloud in like some agnostic way where maybe this code runs on this computer, this code runs on this other computer, and everything else. Um, and so that ends up being kind of a huge part of it.
Absolutely. And as you know, this is something we think a lot about at Metaflow and Outerbounds, minimizing the friction between prototype and production and that iterative cycle as well. And this is sheer shameless self-promotion. But I'm actually okay with that, and I'd probably have to fire myself if I didn't. But we've
It is
actually
your
just
job.
yeah, exactly. We've just announced our Metaflow and GCP Google Cloud Platform integration, which completes. We are now officially multi-cloud. But the reason that's actually relevant, besides mere shameless self-promotion, is that you're able to send your code from your local workstation to any cloud with virtually no code changes. Essentially, you require some basic configuration changes, but that's incredibly important to us. So I'm linking to our blog post in the chat. I'm also going to link to a video that my colleague and CEO, who Ville, created, of showing how you can do very small tweaks to Metaflow code to get it on all the major clouds as well. And essentially that's, we're very interested here in creating human-centric frameworks and software that allow scientists to do these types of things as frictionlessly as possible. So I'm really glad that you brought that up. But
Yeah,
you
I think like
didn't. Yeah,
go ahead.
please. No, you go.
Yeah, I was gonna say, like, I think a difficulty in all of this is that, like, you talked about these like human-centric flows, right? And machine learning comes from data science in some sense, right? And like when we think of data science, it's very interactive experience, right? You're kind of like inspecting your data from different angles. You do the same thing with machine learning models. You try out different parameters, maybe you try out different features, different inputs. And so you kind of have this like very iterative loop that you're dealing with, which means that you want a lot of interactivity. But then at the end of the day, if you actually want to deploy this, you kind of want to freeze everything into a robust pipeline.
Yep.
And I
Exactly.
feel like these two pieces are at total odds with each other. Like
Yeah.
the workflows for interactive work are very different than like the job of a data engineer, where I now want to have one single pipeline that you cannot change at all because I want to guarantee that it's going to run the same way every day and not break.
Yeah.
And like being able to bridge that gap is where it's important to have, I think, good abstraction layers that allow you to both be interactive and kind of freeze what you've done.
Yeah, very much so. And this actually makes me think of something I probably talk about a bit too much, which is that the idea of writing code itself is overloaded, right? That software engineers will say, oh, data scientists aren't real programmers. And of course they are. They're just using it for a totally different purpose a lot of the time, right? So you're doing science, exploratory data, model building, that type of stuff, which is writing code and it's programming, just doing it for a very different use case. And now we're seeing the convergence of these two different types of programming, right? And figuring out how to actually approach that space.
Yeah, and they're totally different types of programming. I mean, I remember when I got my first job and I looked at some of like the software engineers code at the company and I was like, man, this is so inefficient. Like, why are they writing these big for loops and putting all of this like very like explicit checks in there? Why aren't they like vectorizing everything and everything else that I was used to in my scientific programming? But the reason was that they weren't focused on highly optimized code like you might be focused on in scientific programming. They were focused on writing very clear, testable, readable code, which can sometimes be at odds with with like scientific code.
Yeah.
So and there's like these are both totally different skills. And I think the hard thing is the world of machine learning engineering, where you are trying to write optimized code, but also have it be clear, readable, testable, and everything else.
Yep. Exactly. So we have a lot of great questions in the chat, and we're not going to get to all of them. But I am, for those who weren't here earlier, we're having an AMA, Ask Me Anything, on async on Slack, and I've pasted the link to that. So any questions that we don't get to, jump in. I'll try to copy and paste a bunch of them as well. But get in there and ask them after the fact, as soon as possible. Ethan, I did want to talk about how data scientists at Square and perhaps elsewhere where you've worked interact with platform engineers, and how your data scientists have enough independence to do their work when platform engineers aren't on your team.
Yeah. So
and maybe start by telling us what a platform engineer is, if we've kind of tangentially touched that. But
yeah, so we have like a machine learning platform at Square, and there are engineers that build that platform. And so an example of what they've built is, I think I mentioned this earlier, they might have a model hosting service. So you can upload some model artifacts, some model that you have trained and like saved to your disk. You can upload it to their system, and they will deploy your model and have it, score different events that are flowing through our pipelines and stuff. And they maintain that service to make sure that it's performant and everything else. And so there's also like services. There's also like platform level tools for training your models in the cloud and other sorts of applications here. And so those teams exist. And I think on my previous team, I used a lot of those tools. And so it's like definitely beneficial to have platform level tools. Like Square's the biggest company that I'd worked at before, and it's kind of like amazing to have entire teams of people that are working to build stuff to help you to do your job. I mean, this is like stuff that I would have killed for at tiny startups and things like that. At the same time, the platform only supports what it supports. And by definition, a platform, it's a platform. They have to support lots and lots of different teams and lots of different use cases. Every team has their own, unique use case that they want some new feature of the platform, and the platform can only do so much. And so there's this cost and this benefit to working with a platform. It's the same as bringing a tool in, right? So if you choose to bring in like a machine learning tool to your team, you are now kind of beholden to this tool, and that tool is built by a company, and that company may have their own roadmap of things that they want to build, and you might not be able to get that feature that you want built into their product. The flip side to all of this is that you build it yourself, right? And so that's what my team currently does right now. Is we build like we do a lot of our own infrastructure for training and serving models. And on one hand, it's nice because we have full control. Um, like this is a thing that when I first started programming, I liked programming because there's like nobody to blame but yourself if the program's not working. And so it's kind of like responsibility is kind of nice in a way where it's like, all right, like can't blame anybody else. Like I'm the one who has to fix this, and so be it. And so we build our own stuff, which means that we're able to kind of support various more advanced use cases that my team has. Like we need to deploy our models on GPUs. We need to do kind of more modern natural language processing and things like that. At the same time, it's a lot of work to build all of that infrastructure and have to have like the deep machine learning knowledge to train models and deploy them and everything else. And so it's definitely a trade-off.
Mm,
But it's been a good one for our team so far.
great. I wish we had more time because there are so many. We had a lot more we want to talk about. There are so many interesting questions people have, but we can continue this on Slack. I think coming back to your journey, and Josh did have a question around this, which I think is important to think through career paths in data science and machine learning and AI now. Maybe you can tell us a bit about your journey to becoming a team lead, the trade-offs between ICs and being a team lead, and then what advice you'd give data scientists who want to become team leads.
Yeah, so this is actually the second time that I've managed. So at the second startup that I worked at after grad school, I started out as an IC and ended up managing a team there as well. Moved back to being an IC, and now I'm a manager again. And so I think, and there's this great blog post from Charity Majors, I think, called like the Manager Engineer Pendulum or something like that.
Yeah, I'm gonna search that while you talk and try to find it.
Yeah, which is all about how you kind of don't have to pick one path and then be stuck down it. And so I think that that's true. I've kind of oscillated back and forth between the two like a pendulum, and so I think that's one thing to call out. There's definitely differences to either role. I would say that like the IC role in many ways like is IC role is very appealing. So I think a lot of us write code on this call, and like uh it's really nice when you write code and it runs. Like you kind of get this like little dopamine hit, and you're like, oh my God, like wow, like I figured this out. You feel really good. And it's nice to get to do that day in and day out. And then if you can get a job that actually pays you to do that, that's even better. Um, and and yeah, and like our field is interesting and everything else. And especially like larger tech companies like I'm at now, we have an IC track and we have a management track. And like when I moved into being a manager, there was no difference in compensation. These are both kind of like held at the same level at this company. And so then like maybe it's like why would you want to do management at all? And so I think like there are definitely benefits to doing managing as well. One thing is like I like mentoring people. I I co-taught a class with our friend Jacopo this past semester, and like I like teaching people. I write on my blog because I like getting emails from people that like read and learn things, and I really like working with my team right now. Like I have a great team of machine learning engineers, and like I enjoy that mentorship aspect and kind of like lifting them up. Um, the other piece I think is like I kind of like having the broader view of things. And I found, when you're like, I think we've all like gotten into the zone while coding before, where it's kind of like you have like your nose in a book, like really really deep in the book. You kind of get tunnel vision to the outside world. And when you're doing that, a lot of the times it's kind of harder to have like a higher level view of like your team, the application that you work on, the business as a whole, and things like that. And I like having the space to think about that stuff and be able to also have some impact on that side of things. And so that was part of the reason why I ended up moving into managing this time, because I'm interested in the product. I have like, yeah, I'm generally interested in it, and I like kind of like having some influence there and having like the mental space to think through those things. But at the same time, it's it's definitely a trade-off because I don't do nearly as much programming anymore, and when I do programming, it's not at the same quality as when I used to do it.
Yeah, absolutely. And I do like the idea of the pendulum, or revolving door, if you will. I suppose it is more of a pendulum, and something I think you and I clearly both considered was at that point in time was a lack of a revolving door between academia and industry, right?
Yeah, I mean, especially in physics. Like if I had done a PhD in computer science, I think that world, like, it's very fluid. You can move in between, but once you
And
leave
a lot of
physics,
the
you're gone
big
for good.
dogs in computer science do both these
They're doing
days,
both. They get to
Yeah,
have their cake and eat it too. It's
exactly.
quite a nice situation for them.
Yeah. Awesome, Ethan. Well, we've got a lot of people saying thank you in the chat, and Todd Garner even says great chat, gents. So thank you, Todd. We didn't get to answer all the questions, but do join us in Slack for our Ask Me Anything with Ethan, and I'm happy to answer any questions there as well. Thank you all for joining, but in particular, thank you so much, Ethan, for sharing your wisdom and having a great conversation, and as always.
Of course. Thank you so much, Hugo. This was awesome. And thank you everybody else